Good day friends, in our previous lecture we studied about first equation of motion, right? Now first equation of motion is basically a relationship between initial velocity, final velocity, acceleration and the time interval, right? Today we are going to discuss about the second equation of motion, right? Let's have a look. V is equal to u plus at that we studied from first equation of motion, right? Now the second equation of motion can be derived with the help of differential calculus, right? Now, as we know that velocity v is defined as ds by dt. Now, ds by dt are basically the ratios of differential displacement over differential time, right? As the time interval is very short and the displacement is also very short, right? Now, from this equation, what we can write, v dt is equal to ds. Okay. Now here what we can replace? We can replace v is equal to u plus at from equation of motion, which is equal to ds, and then we can put an integral sign over here. Now we will be getting u dt plus integral at dt, which is equal to integral ds. Okay. Now what do we have to do? We need to put the limit. This will be equal to 0 to t. Again this will be equal to 0 to t, and this will be from 0 to s, correct? Now this one will be ut plus a integral 0 to t, then t dt is equal to s 0 to s. Now as we know that integral x dx is equal to x square by 2, right? So hence this will be a then t square by 2. Now see, this is t dt, and as we know x dx integral is x square by 2, means the general formula is, let's suppose if this is n, integral x raised to power n dx is equal to x raised to power n plus 1 upon n plus 1. This is the formula, right? We have applied that formula over here. Okay, now this is s. Now this is ut plus half a2 square, which is equal to s. So hence we can conclude s is equal to ut plus half a e square, correct? Now this is the second equation of motion. Now the beauty of this second equation of motion is, whenever you have been given a displacement, an initial velocity, time interval, okay, so you can find out acceleration. So here how many unknowns are there? S is here, u is here, t is here, and a is here. Again 1, 2, 3, 4. 4 unknowns are here. Any 3 can be given, and the fourth one has to be found, right? So we are going to we will definitely apply this formula in solving the numerical problems. Okay, if you want to note it down, you can note it down. Now we are moving ahead towards the third equation of motions, right? third equation of motion. Okay. Now third equation of motion, basically, as we know, V is equal to u plus at, right? This is the first equation. Now what you have to do is basically squaring both LHS and RHS. What will happen? We will get V square is equal to u plus at whole square. Right? This point is clear. Now, on expanding, we will be getting V square is equal to u square plus at whole square plus 2 times u at. Right? Now, what is this? How we got this? This is a simple square of x plus y whole square, which is equal to x square plus y square plus 2xy. Right? This is the application for this formula. Now next, v square is equal to u square plus a square t square plus 2 u at. Right? Now here what we can do, v square is equal to u square plus, let's take 2 a as common. Right? So what we will be getting here, now this is, we are taking 2a as common. So here what shall I have to write? 1 by 2 then a and t square plus, now here 2a has been taken as common, so we will be getting ut. Correct? So hence we can write v square is equal to u square plus 2a, and this one we can just rearrange the term ut plus half a t square. Now u square plus 2a. Now what is this term? If you see that equation of motion number 1 was v is equal to u plus at, and second was s is equal to ut plus half at square. This was second equation, right? This is the same thing. What we can write it simply 2as. So what we got finally, v square is equal to u square plus 2as, hence making it equation number 3. Right? So hence we have understood all the 3 equation of motions, starting with v is equal to u plus at, s is equal to ut plus half at square, and finally v square is equal to u square plus 2as. Right? Now let's have a look. This equation contains v, u, a and s. 1, 2, 3, 4. Again 4 unknowns. Right? So any 3 may have been given and we need to find the 4th one. Correct? We can write third equation of motion, v square is equal to u square plus 2as. Right? Now the other thing is it possible every time that there will be an acceleration? There may be a retardation also. Retardation means the initial velocity must be higher and the final velocity must be lower. So in that sense, what we can conclude, that all these equation of motion will be converted as v is equal to u plus minus at, then s is equal to ut plus minus half at square, and then v square is equal to u square plus minus 2as, right? So plus a can be used for acceleration, right, and minus a for retardation. Correct? This point is clear? Okay? Fine. Right? Now, straight line motion under gravity, right? Now, earlier what we have studied is basically the straight line motion of a body on horizontal plane, correct? Now we will study about, of course, the straight line motion in vertical plane, right? So basically the vertical plane motion of a body under gravity, right? So this will be also a straight line motion under gravity. Means, let's suppose if any body is dropped from a height h, okay, now under free fall, what will happen? U is equal to 0. Now what is U? U is the initial velocity. Now here when a body is dropped, what's going to happen? Acceleration due to gravity is g, which is of course generally 9.8 meter per second square if it is not given. Correct? Throughout this journey of this small object, the constant acceleration is 9.8 meter per second square, which is of course gravitational acceleration. So the same equation of motions in a straight line can be written as v is equal to u plus minus gt, and then h is equal to ut plus minus half gt square, and third v square is equal to u square plus minus 2gh, right? Right? Means when a body is dropped like this or a body is thrown upward like this, correct? In both the situation we can use these three equation of motions, right? I hope you must have understood all the concepts which we have discussed in this lectures, right? In our next lecture we will be doing some numerical problems based on the straight line motion of an object, right? Till then, take care, bye bye, thank you.